Hey students, this is a lecture on triple integrals. So we've already talked about single and double integrals, and double integrals are similar to triple integrals. It's just triple integrals have three variables. Okay, so we're dealing with three separate variables. And just like with double integrals, you want to work from the inside outward, so you want to do the inside integrals first. Okay, so work from inside integral outward. Okay, in other words, do the innermost integral first. Just like double integrals, really. And you keep the other variables constant. So whatever integral you're working on, for example, if you're integrating with respect to y, the other two variables, x and z, are both going to be constant. Okay? Alright, so let's see some examples of this. It's actually a pretty fun topic. I actually really like these. It's a lot like Calculus 1. It's just a little bit more complicated because it has more variables. Okay, so example. Evaluate each integral. Evaluate each integral. Okay, and for problem number 1, we're going to do the triple integral. So triple integral from 0 to 4, from 0 to 3, and 0 to 4. Triple integral from 0 to 4, 0 to 3, and 0 to 4 of the quantity x squared plus y squared plus z squared. Okay, dz, dy, dx. Okay, dz, dy, dx. So probably the hardest thing is just keeping track of all the variables. It's just like a double integral, but there's an additional variable. So one thing that people like to do, and that I recommend, is since you're starting with the innermost integral, you circle that. So the innermost integral here is dz. And since it's with respect to z, that means these limits of integration are in terms of z. So this inner integral is going from z equals 0 to z equals 4. And you just want to focus on this inner integral first. So remember, when you're integrating with respect to z, that means the other two variables are constant. So here, x and y are both constant. Okay? Alright, so since x and y are constant, that means x squared plus y squared is constant. So the integral of a constant is the constant times a variable. So what we're going to get here is we're going to get x squared times z plus y squared times z. Because those are both constants, so their integral is the constant times a variable. And then for z squared, we're going to go ahead and use the power rule. So we go ahead and increase the exponent by 1, and we divide by the new exponent. So it becomes z to the 3 divided by 3. Okay, so we're going to have plus z cubed divided by 3. Right, and this is evaluated from z equals 0 to z equals 4. Alright, and if you want to make your life a little bit easier, one thing you can do here is you can always factor out a z if you want to. So maybe we'll do that. Since there's a z in common for all three factors, we could factor out a z. or you can just leave it the way it's written. But I'm going to go ahead and factor out a z. So we have z times a quantity x squared plus y squared plus z squared over 3. Alright, and we want to evaluate this from 0 to 4. Okay, so you plug in the top number in for z. So this is going from z equals 0 to z equals 4. So we're going to get 4 times a quantity x squared plus y squared plus 4 squared over 3. Okay, minus, well, for the next one, we have 0 times a quantity x squared plus y squared plus 0 squared over 3. But for this second term, because it's multiplied times 0, this whole thing right here is going to be 0. Okay, so this whole thing is just 0, because 0 times any other number is just 0. Okay, so really all we have to simplify is this over here. So over here, we can go ahead and distribute the 4. Maybe it wasn't so great to factor out a z, but I like to factor out a z when you can. So we're going to go ahead and distribute the 4. Okay, so we get 4x squared plus 4y squared plus 4 cubed over 3. Okay? And then for the 4 cubed, well, 4 times 4 is 16, and 4 times 16 is 64. So this 4 cubed is actually going to be 64. Okay, so far, for our integral, we now have, we've done the inner integral, and we now have 4x squared plus 4y squared plus 64 over 3. And maybe I didn't need to distribute the 4, I don't know. I'm just kind of playing it by ear like I always do. Okay, but we've done the innermost integral, so now we're going to do the middle integral. Okay, so here the middle integral is the integral from 0 to 3 dy. Okay, the integral from 0 to 3 dy. So that's the one that we're going to be doing next. So integral from 0 to 3 of this whole thing, dy. Okay, and I guess technically I probably should have just left the 4 out front, but oh well. So if I go ahead and factor out that 4, that'll make my life easier. But that's how it is in calculus, you know. Sometimes you have an idea and you think it's going to be a good idea, but like distributing that 4 was just a waste of time. So, so what we got here is I brought the 4 outside of the integral, and then we have the integral of x squared plus y squared plus 16 over 3. And this is dy. Remember, we still have the outermost integral, but we're just doing one integral at a time. Okay, so this is the middle integral. And for this one, since we're integrating with respect to y, that means the other variables are constant. So here x is constant. Okay, so here x is constant. And z is also constant, but I don't need to write it because we don't have any z's here. But z would also be constant if you still had a z in this step. So since x is constant, x squared is constant. And so the integral of a constant is that constant times the variable. So what we're going to get here is x squared times y plus, well, the integral of y squared, we have to add one to the exponent and divide by the new exponent. So that's going to give us y cubed over 3. Okay. And then 16 over 3 is once again a constant. So that's the integral of that is going to be 16 over 3 times y. Okay, so we're going to have 16 thirds times y. All right, and then this whole thing has a 4 out front. Don't forget about the 4. And this is going to be evaluated from y equals 0 to y equals 3. And last time factoring out the variable didn't really seem to help that much. So I think I've learned my lesson, and this time I'm not going to factor out a variable. The only thing that I will factor out here is maybe a 1/3, just to make it so we don't have fractions on the inside. So I'll go ahead and factor out a 1/3 from the whole expression. So we're going to have a 4/3 out front. And then on the inside, for the first term, we'll have 3x squared y, because 3 over 3 is 1. And then for the other two terms, we have plus y cubed plus 16y. Okay, and this is evaluated from y equals 0 to y equals 3. So now we're going to go ahead and plug in. So plugging in the top number, plugging in 3, we have 3x squared times 3 plus 3 cubed plus 16 times 3 minus the rest of it, which is going to be 3x squared times 0 plus 0 cubed plus 16 times 0. But all this is just going to be 0. And don't forget, we still have a 4/3 out front. Okay, so we still have a 4/3 out here. Okay, and then simplifying, 3 times 3 is 9. So here we have 9x squared plus 3 times 3 is 9 times 3 is 27. So 3 cubed is 27. And then 16 times 3 is 48. Okay, so we have 9x squared plus 27 plus 48. And we still have a 4/3 out front. And here, technically, you could distribute the 1/3 if you wanted to simplify it a little bit. So I guess we could do that. So we'll go ahead and distribute the 1/3 and divide everything by 3. So we're going to have 4 times 3x squared. Am I missing something here? Was this really just a y cubed? 3 cubed. No, we're good. Okay. Okay. So the 27 plus 48, we can do that after we distribute the 1/3. So 27 divided by 3 is 9, and 48 divided by 3 is 16. Okay, and then 9 plus 16 is 25. Right? Okay, so we have 4 times 3x squared plus 25. All right, so we just finished the middle integral. So now we have to do the outermost integral. Again, we're working our way from the inside outward. So for the outer integral, we're doing the integral from 0 to 4 of this whole thing dx. Okay, but that whole thing is now simplified to just this. Okay, so this is going to be the integral. The outer integral is going to be the integral from x equals 0 to x equals 4 of this thing dx. Okay, and obviously you can bring the 4 out front because it's a constant. And then using the power rule, we're going to have a 4 out front, and then for the x squared, we add 1 to the exponent, and then we divide by the new exponent. So it's actually going to give us 3x cubed divided by 3. And then the integral of 25 is going to be 25x. And we're evaluating this from x equals 0 to x equals 4. Okay, so we plug in the top number first, and then we subtract the whole function evaluated at the bottom number. Okay, so we have 4 times 4 cubed plus 25 times 4 That's the entire function evaluated at 4. And then we subtract the entire function evaluated at 0. So that's going to be minus 0 cubed plus 25 times 0. And any number times 0 is 0. So all this is just going to be 0. And then 4 cubed is actually going to give us 4 times 4 is 16, times 4 is 64. Okay, so we have 64 there. And then everyone should know that 25 times 4 is 100, because there's 4 quarters in a dollar. Okay, so we have 4 times 64 plus 100. Okay, so that's going to be 4 times 164. And I could probably do that in my head. I think it's like 656 or something, but why bother when we have a calculator? So let's just type it into a calculator real quick. So 4 times 164 is 656. Okay, so I was right. Okay, cool, so that's our first problem. And obviously that one example took me a while, so I can't do a lot of examples, but I am going to do at least one more. Okay, so for our next example, what we're going to do is we're going to have an iterated integral, iterated triple integral. And by the way, these are all called iterated integrals because they're already set up for us. But I'll do one more example after this that's not an iterated integral. It'll actually be one where we have to set it up. Okay? All right, so for number 2, we've got the integral from 0 to 6 and the integral from 0 to the square root of 36 minus x squared, and the integral from 0 to the square root of 36 minus x squared again. So same limits of integration for those two inner integrals. Okay, and this one's going to be dz, dy, dx. And this one happened to be in the same order as the other one, but keep in mind you don't have to have these in a particular order. So for example, you could have dy, dx, dz, or dx, dy, dz. Any of those orders is fine, but it is important that you work your way from the inside outward. So you start with the innermost integral first. So the nice thing about this problem is we don't actually have a function to integrate here. So it's actually, it looks complicated with all this, but it's actually not that bad. So let's take a look at this. So let's start with our innermost integral. So our inner integral is dz, which means these limits of integration are for z. Okay? So we start we plug in the top and subtract the bottom. Now, what is the integral of dz? Well, that's just the same as the integral of 1 dz. The integral of 1 dz, because 1 is a constant, is that constant times the variable. So that's actually just going to give us 1 times z. But remember, if you have something times 1, you don't need to write the 1. So the 1 was just there for you to understand how it works. Okay, so for our inner integral, we just have z. And this is going to be evaluated from z equals 0 to z equals square root of 36 minus x squared. Okay, so we have a lot to plug in here, but fortunately the function itself is very simple. So we plug in the top number first. So we plug in square root of 36 minus x squared, and then we subtract the bottom number. So we subtract 0. Okay, and then any number minus 0 is just a number, so we don't need this down here. So for our inner integral, we now have the square root of 36 minus x squared. So that finishes our inner integral. Now we do our middle integral. So I'll do that one in blue. So here our middle integral is the integral from 0 to square root of 36 minus x squared dy. Okay, because that's in terms of y, these limits of integration are going to be evaluated in terms of y. Okay, so for our middle integral, we're doing the integral from y equals 0 to y equals the square root of 36 minus x squared, and this is dy. Okay, but because the integral is with respect to y, that means that other variables are constant. So the only other variable here is x, and x is constant. So believe it or not, since x is constant, that means x squared is constant. So 36 minus x squared is constant, and the square root of a constant is still a constant. So this whole thing is just a constant, and we can factor it out from it. So it looks a little strange, but we can actually factor out this entire square root of 36 minus x squared. So that just comes out front. And then we have our integral dy. Okay? But for the integral dy, the integral of dy is just y. Okay, so we wind up with y right here. And y is going to be going from 0 to square root of 36 minus x squared. And now we have a square root of 36 minus x squared out front. Okay, so we're still working on the middle integral. Okay, so plugging in the top first, we get the square root of 36 minus x squared minus 0. And then we still have a square root of 36 minus x squared out front. Well, any number minus 0 is just a number, so this goes away. And now we can simplify this. Square root of 36 minus x squared times the square root of 36 minus x squared. Well, a square root times itself is just canceling out with the square roots and just gives you what's on the inside. Okay, so here the square roots cancel, and we just wind up with 36 minus x squared. Okay, so that finishes the middle integral. And now all we have to do is the outer integral. So going back up here, our outer integral, I'll do that one in green. Our outer integral is from 0 to 6 of dx. Okay? So that's going from x equals 0 to x equals 6. So we have the integral from x equals 0 to x equals 6 of 36 minus x squared dx. Okay, so integrating the constant 36, we get 36x, and then integrating the variable, we add 1 to the exponent and we divide by our new exponent. Okay, so that's going to be minus x cubed divided by 3. So we have 36x minus x cubed divided by 3. Alright, and then this is going to be evaluated from x equals 0 to x equals 6. Okay, and then plugging in the top number into the entire function, we're going to get 36 times 6 minus 6 cubed over 3. And then we subtract the entire function evaluated at 0. But that's just going to be 0 here and 0 there. So this is just going to be minus 0. Okay, and we don't care about the minus 0. That doesn't matter. So all we care about is simplifying this over here. So to simplify this, 36 times 6, I don't remember what that is. 36 times 6 is 216. And I probably should have known that. Okay, so we have 216. And then what's 6 cubed? Well, 6 squared is 36. And 6 times 36, we just said, was 216. So we have 216 minus 216 over 3. Okay? And then 216 divided by 3 on a calculator is 288. What? I did not do that right. I must have typed it in wrong. So 216 divided by 3 is 72. Okay, so we have 216 minus 72. Okay, and 216 minus 72, again, just using a calculator to be lazy, is 144. Okay, so our answer is 144. So that one was also a lot of work, but hopefully not too bad. Okay, and if you need any extra help, you have my office hours, and you can also go on to the My Math Lab View and Example and help me solve this. But there's only one more that I wanted to do in this lecture. I wanted to do an actual triple integral where we have to set it up. Okay? Okay, so this is a new example. Find the volume of the region. Find the volume of the region between the cylinder z equals 2y squared and the xy plane. Okay, so find the volume of the region between the cylinder z equals 2y squared and the xy plane that is bounded Okay, so bounded means it's enclosed by. That is bounded by the planes x equals 0, x equals 3, y equals negative 3, and y equals 3. Okay. Find the volume of the region between the cylinder z equals 2y squared and the xy plane that is bounded by the planes x equals 0, x equals 3, y equals negative 3, y equals 3. Okay, so for this one, they don't have the iterated integral set up for you. So here we're actually going to have to set it up on our own. There's only one of those on your homework though. So, and it's pretty similar to this one, just with different numbers. So what we're going to do here is we're probably going to need to sketch a picture. So remember, when you're drawing your picture, the standard thing is to have the plane that comes out at you be your x-axis. So here's the x-axis. The horizontal one is the y-axis. And then the vertical axis is your z-axis. Okay, so your vertical axis is your z-axis. Okay, and you don't have to do a sketch, but a sketch sure does help here. Okay, so first of all, let's start with the easy parts, which is that we know that x goes from 0 to 3, and we know y goes from negative 3 to 3. So we're going to be able to graph those pretty easily. The part that's hard to graph is this, z equals 2y squared. But keep in mind that z equals 2y squared is just going to be a parabola that opens upward, and it's multiplied times 2, so it's going to be stretched by a factor of 2. So on the z and y plane, we're going to have a parabola. So just for our sketch, we'll have a skinny parabola on the zy plane. Okay, that's fine. I'm a terrible artist, as you can see. You already knew that. But that is the zy plane. Okay. And we want the cylinder of, when they say cylinder, they mean z equals 2y squared is that right there, that I sketched right there. That's 2y squared. And it also needs to be bounded by the xy plane. So the xy plane is this horizontal plane. So we're going to be starting at this horizontal plane, the xy plane, and we're going to be going up to z equals 2y squared. Okay, so now what else do we do? Well, we know x goes from 0 to 3. So remember, the positive x comes out at you like this. So x is going to start right here at 0. And then it's going to come out at us, and it's going to end at 3. Right there, that's 3. Sorry, having trouble writing small on this thing. Okay. And then we know that y goes from -3 to +3. So y is going to go down to -3, 1, 2, -3. And it's going to go up to +3. Okay, so we're going from here to here. So what's that going to look like? Well, basically, we're just going to have this shape, the z equals 2y squared, but it's going to be a cylinder. And what a cylinder is it's going to be limited. Whoops. What am I thinking? I just had a brain fart. So I did the y equals -3 and the y equals 3 on the z-axis. Wow, that was a big mistake. Oops. I think I'm going to leave it in the video, though, just so that you know I'm human. Okay. So that was a big mistake. So I accidentally thought that the y-axis was the z-axis. Okay. So I'm sorry. Y goes from -3 to +3. So that's going to be on this horizontal axis here. Okay, so -3 on the left and +3 on the right. And remember, this is just a sketch, and you don't have to do the sketch, but I wanted you to have an idea about what this is going to look like. Okay, so now that I have it on the correct axes, I think we can sketch this now. So what we're going to have here is we're going to have a cylinder that goes, it's a little bit hard for me to draw this, but we have a cylinder that goes from x equals 0 to x equals 3. I should probably just give up my career in art right away, because this is hard. But well, anyway, let me see. Let me get this shape right here. Boom, boom, and then this shape over here. Boom. Okay. So obviously it would be helpful if I were better at drawing, but I'm not. Okay, so anyway, what we got here is I'm trying to sketch this cylinder, which is difficult for me. But I hope you can kind of get the idea from my drawing. And this cylinder is also going to be going straight down to here, down to 3, there, and down here. Also going down to the same location. So anyway, I can't talk very well when I'm drawing, but I think we get the idea. Yeah. Okay, actually that went better than I thought it was going to go. I was worried my drawing was going to be absolutely horrible. But instead it's just bad. It's not horrible, it's just bad. Okay. But my math lab, you can also use GeoGebra, but I wanted to actually draw one by hand just so that you can see that that's something that you can do. But GeoGebra would probably make this a whole lot easier. Okay, so this is going to be our region of integration. Region of integration. All right, and then how do we set up this integral? Well, what we want to do is, since z is in terms of y here, remember on the last example, notice how they set up the integral? Actually, not the last example, but notice that if you start with the right variable, your integral is going to be easier. So that's what I'm trying to get at here. So we need to be smart about which variable we choose for our innermost integral. We need to make it be one that's not so bad. So for example, since we have the only function we have here is z equals 2y squared, it might be smart to have our innermost integral just be dz. Okay, so I think I'm going to have the inner integral be dz. So we're going to have integral dz, and then we'll have dy and dx. And this is the most popular way to write it, so that's probably why they had the problem set up this way. And then the tricky part is plugging in. But we know that for z, which is going to be our innermost integral, we're going to be going from z equals 0. Now, how did I get 0? Well, it said it was bounded, the region was bounded by the cylinder z equals 2y squared and the xy plane. So the xy plane is right here. So that's actually bounded at z equals 0. So z goes, if I do z in green here, z goes from 0 all the way up to here. Okay? And what's up here? Well, up here is actually z equals 2y squared. Okay? So that parabola there is z equals 2y squared. So we're going to go from z equals 0 to z equals 2y squared. Okay, that's our innermost integral. And then our outer integrals are going to be a lot easier. So for the dy, we know that y goes from -3 to 3. So that's going to be our middle integral. So y goes from -3 to 3. And then our outer integral is dx. Remember, you work from the inside outward, so from left to right. That's the innermost, middle, and outward. So for dx, we have x goes from 0 to 3. Okay, the integral from x equals 0 to x equals 3. Now you might be wondering, well, how come there's no function in here? Well, actually, when you're finding volume, when they ask for volume, usually there's not going to be any function. So it turns out that if you want to find the volume of something like this, you don't even need a function. You literally just need to set up your triple integral. So once you do that, after you integrate all three variables, that gives you your 3 dimensions. And 3 dimensions is the number of dimensions in volume, right? You have x, y, and z, 3 dimensions. So that's why you don't need a function, is because it's volume. Okay, and that makes our life a lot easier. So this shouldn't be so bad. So let's start with the inner integral. So the inner integral is dz. So plugging in the top first. Well, remember the integral of dz is just z. So we're going to be evaluating z from z equals 0 to z equals 2y squared. Okay, so plugging in the top first, we get 2y squared minus 0. Okay, and that's our innermost integral. But any number minus 0 is just the number, so we don't need this. And then for our middle integral, we're going to be evaluating y from negative 3 to 3 dy. So we're integrating dy. Okay, so we're doing the integral from negative 3 to 3 of 2y squared dy. And here we can just use the power rule. So we add 1 to the exponent and we divide by the new exponent. So we're going to get 2y cubed divided by 3. Okay, and this is going to be evaluated from y equals negative 3 to y equals positive 3. Okay, and I'd recommend just factoring out the 2/3, just because it's a constant. It'll make our life easier. So we'll factor out the 2/3, and then plugging in the top number first, we're going to have 3 cubed minus negative 3 cubed. Okay, 3 cubed minus negative 3 cubed. And then here, 3 cubed is going to be 27. And negative 3 cubed is going to be negative 27. But there's a minus out front, so those minuses cancel out. So we actually have 27 plus 27, which is 54. Okay, so we have 2/3 times 54. Okay, and then because I'm lazy, I'm just going to do it on a calculator. If I do 2/3 times 54, that gives me 36. Okay, so this simplifies to 36. And that finishes our middle integral. And that middle integral was with respect to y. So now let's do the outer integral. So the outer integral is dx. Integral from x equals 0 to x equals 3 dx. Okay, so let's do that one. Integral from x equals 0 to x equals 3 of 36 dx. So the integral of a constant is the constant times a variable. So this is just going to be 36x. And we're going to evaluate this from x equals 0 to x equals 3. Alright, so plugging in, we get 36 times 3 minus 36 times 0. Okay, and any number times 0 is 0, so we don't care about the 36 times 0. And then 36 times 3. 3 times 3 is 9, and 3 times 6 is 18. So I'm going to say that's 108. I really should not use a calculator, but just to check myself, 36 times 3. Yep, that's 108. Wow, I can do math. Okay, so we got 108. And let's see, let me just make sure that's what they got. Otherwise I made a mistake or something. No, we got it. So that is a real triple integral problem. Okay. Thanks for watching. Happy mathing.